All right, the last of our examples where we're combining these into a single logarithm is this. Again, I'm going to use natural log just because it's convenient, and the point is it doesn't matter what base. You eventually end up using natural log all the time anyway, so I'm just going to sort of grease the skids here a bit, and I'm going to use natural log in several of these examples. We have the natural log of x plus 4, that's a binomial, minus the natural log of another binomial, and that's minus the log of another binomial. All right? So maybe what the thing to do here might be, see if you can work this by yourself. Remember, treat x plus 4, treat x minus 1, treat x minus 4, leave them in parentheses and just treat them as if they were a single entity. So once you try to work this by yourself, and then we'll come back and see if you got it, see how well I can match your answer. So why don't you go ahead and pause the video now if you like. All right, let's see how well I can do, see if I can get what you have. First thing, we have to get rid of this 2, move it up as the exponent rather than the coefficient, apply property 3. Nothing's going to happen with these just yet. So this is the natural log of x plus 4 quantity squared, minus, again, do nothing, and do nothing. That's my best thing. Now we have all of our ducks in a row. We have natural log, all the coefficients are 1 or negative 1, and so now we can combine these into one great big natural logarithm. And any logarithm that's positive, that argument goes in the numerator. Any argument that's negative, that argument goes in the denominator. You don't need to square this out. If you do, you need to do it correctly. But the best thing to do is just leave this as it is. X plus 4 to the second goes in the numerator because that log is positive. Both of these arguments go in denominator because those logs are negative. And that's all there is to that. So you should now be able to practice combining a statement that involves several logarithms, combining those into a single logarithm.